Same guy, as we say that this is our general structure, and you can have substitutes at position 5. We can also substitute this hydrogen atom at position 3 at the end 3, and also this oxygen atom at position 2 can be substituted. For long acting, this N3 can be substituted. So we can have at this position N with a methyl group, or we can have N with H, this one. For intermediate acting, N3 is always NH group. Even here it will be NH, and also here will be NH. That's C at position 3. Then for the position 5, that's carbon, at carbon number 5 here, you can have an ethyl group for long acting. You can have 2 of them when R5 and R5 prime are all ethyl groups. Or we can have one is a ethyl group, one can be an ethyl group, another one can be a phenyl ring. So let's do this. Now for the intermediate acting, the carbon number 5 here, we can have ethyl group, and we have another chain at another one. The R5 can be an ethyl, then R5 prime can be a 3 to 5 carbon structure, or chain can be 3 to 5 carbon chain. Or we can have a allyl, that's a chain with double bond and a 3 to 5 carbon chain for the intermediate acting. Then here for the short acting at R5, you can have the same. You can have one with ethyl, but here it will be 5 carbon. There is no option. It is ethyl and 5 carbon chain. Or you can have allyl and 5 carbon, not 3 to 5. Here it is 3 to 5. Here it is 5. We are going to see the structures. Then here at ultrashort acting, you can have ethyl and 5 carbon, like here. Also, you can have allyl and 5 carbon atom here. Now, that's position 5. Now, for position 3, at position 3, here, we shall have oxygen. But here, it can be substituted with sulfur. So we may have oxygen or sulfur. This one, we said, increases the lipophilicity, in that the duration of action will reduce. Let's have some examples. Here, long-acting, we have drugs like the phenobarbital. Phenobarbital can have methabarbital, and you can also have a drug called methabarbital. Let's see the structures. For the phenobarbital, it is like this. Here, we said position 3 is always oxygen. Here we said it can be NH or NCH3, but for phenobarbital it is NH. Then here, the phenobarbital, it has an ethyl group, ethyl, and a phenyl ring, So this is phenobarbital. So you can see, for easy understanding, phenobarbital, it has a phenyl ring. This is phenobarbital. For methabarbital, you can have this. Here is OH. Here, now we have a methyl group. We said it can be NH or NCH3. And we said at position 5, we may have two ethyl groups. So for methabarbital, this is the structure. It has two ethyl groups. For methabarbital, this is the structure. Here we have O. Even here you have an oxygen atom. Here also oxygen atom. Now here we have a methyl group. Here we have ethyl with a phenyl. That is methabarbital. Easy remembering. Me means it has a methyl, then this 4 means it has a phenyl ring, so it is methabarbital. M is for methyl, then 4 is for phenyl. So these are the examples under long-acting drugs. And these drugs, they are typically used as anticonvulsants. They are typically used as anticonvulsants. Let's have examples of the intermediate acting. For intermediate acting, we have drugs like amobarbital. Another drug, it is betabarbital, aprobarbital, and taribarbital. For easy remembering, of course, you can see beta-barbital, it has a butane. Apro-barbital, it has a propane somewhere. Taribital, it also has a butane. Yeah, it has a butane somewhere. Let's try and see the structures. For ammobarbital, this is the structure. And we said that here it's always NH. And at position 3, we are having oxygen atom. You can see. Then here we say that we can have ethyl and 3 to 5 carbon atom. For methylbarbital, we shall have the ethyl and a 5-membered structure or chain. 1, 2, 3, 4, 5. That is ammobarbital. This is ammobarbital. Let's try to draw the beta-barbital, but can't fit here. Let's just draw it here and compare here. Beta-barbital, this is the structure for beta-barbital. NH, here we have oxygen, here we have NH, oxygen, oxygen. And this one, charge ethyl, charge and ethyl, and a butane. 1, 2, 3, 4. That is beta-barbital. There's a ethyl and a butane. Apro-barbital. This is the structure. We say that they can be aryl. This is the aryl group. And for apro-barbital, there's a propane. So this is apro-barbital. Now for taribital, this is the structure. Here we have H and H. And also there's an aryl group. And it has a butane. 1, 2, 3, 4. That is taribital. This is ammobarbital. This is beta-barbital. This one is apro-barbital. And this is taribital. Now, when you see these structures and the first structures, you can see that here we have branching, and say that branching increases the lipophilicity, and also the chain increased. This increases the lipophilicity, so it reduces the duration of action and onset of action. So these ones are shorter, they are intermediate acting, and these ones are long acting. Let's see the short acting one and ultra short acting. So these intermediates one, they are also used as sedatives and hypnotics. They are sedatives and hypnotics. Let's see the short acting. The short acting, we say that they have ethyl and 5 carbon, or allyl and a 5 carbon chain. An example, we have the pento barbito and seco barbito. Pento has a pentane straight chain. I mean pentane alkyl chain. This is the structure. I say that here it is hydrogen and here it is oxygen atom. We say that it can be ethyl and can be allyl, but for pentobarbitol it is ethyl and a 5-membered chain. 1, 2, 3, 4, 5. That is pentobarbitol. For secobarbitol, this is the structure. Instead of ethyl, it has aryl group with a double bond, and this chain remains the same. So this is secobarbitol. You can see now, mean that this drug is more lipophilic than this one because just everything is the same, but the difference is here. This one has the double bond. This one it's just an ethyl group. And these drugs are typically used as sedatives, hypnotics. Sedatives, hypnotics. For ultrashort acting, said at carbon 5 can be ethyl or it can be ethyl or aryl with a 5 carbon chain. An example is thiopento and thiamyral. Now, for thiopento is from pentobarbitol. So you can have the whole pentobarbitol. We just change this oxygen atom. So this is the structure. This is the structure. Here we have sulfur, oxygen, oxygen. Everything remains the same. This is thiopento. Then for thiamyral, this one is from the secobarbitol. We just change the oxygen to sulfur. Here we have sulfur, and here we have aryl group. We have a double bond here. Then this is thiamyral. So these drugs, they are typically used as in anesthesia induction. They're used in anesthesia induction. Thiopento. So that's it. Let's have a question and see whether we can answer. Yes, I have a question here. Identify the drug, its barbiturate class, and its use. Please, you can share the answers in comments. Identify the drug, you give the class whether it is short acting, long acting, intermediate, then you give its use, please, in the comment section.